Right. Got about 20 odd people. Good morning, everyone. This is the GSE 102 stream. I'm not Christopher Knowles. He's unavailable at the moment. So I'm almost as muscly and I'd like to think I'm just as good looking. But yeah, I'm Niall Ashley. I'm chairing today. So if you have any questions that you want to ask, any queries about how to submit feedback, please do submit them in the chat, and I'll be happy to directly message you and sort of work that out. Session today is the GSE 102 session from the GSE 102 stream. It's called An Intro to RACF Exits, and it's going to be delivered by Mark Wilson himself, the man, the myth, and arguably a legend. It doesn't need much of an introduction. Mark is, as I was just saying, basically the face of GSE. And not an awful face to look at either. So I'll let him dominate your screens and run right ahead. By all means, Mark, go ahead and don't forget everyone to please submit your feedback at the end. It's session 6F. There are a QR code. There's a QR code at the start and the end. So by all means, go ahead, Mark.
Niall, thank you very much. And the only thing I'm a legend at is being older than I wish to be. Okay, so we won't say much more than that. So yeah, morning everybody. Thanks for turning up to this. The chair of the 102 stream, Chris Knowles, and at the time was David Lee, asked me just to put something together around an intro to RACF Exits, and actually a session I created many years ago. So I've kind of dusted it off, updated it, and add a few more bits into it. Quite happy to take sessions as we go through. If you wouldn't mind popping those questions in the chat window, Niall will moderate them. Niall, if there's a question, just interrupt me. I'm quite happy to take them as we go. So let's jump straight in. So here's our agenda. I'll do a quick intro, talk about what is an exit, talk about the books that you will need to help you do this, talk about the actual exits that exist today, run through coding, some of the coding rules and some of the things you'll need to understand. And then what I've done is picked on a relatively new exit in RACF terms, and we'll do one of those in detail. And what I mean by that is we'll step through how the exit gets invoked, what it sees as input into the exit, what you can do in the exit, and what you can do on coming out of the exit. And then obviously there's time at the end for questions, but as I said, jump in and ask questions as we go along. So a quick intro. Mark Wilson, I'm the technical director at Vitali, IBM mainframe services business. I've been a mainframe techie for just over 42 years, now coming up to my 43rd. Started as an operator, senior operator, shift leader, op support, sysprog, consultant, and now all I do is talk about stuff. I don't really do any real work. Outside of work, I've got one wife and 3 daughters. I don't have any time or money left for anything else, or so they tell me. Most of you will know, who know me, I have a huge passion for motorbikes. I'm a long-suffering West Bromwich Albion fan, which is quite nice because we're doing okay at the minute, and I like a little bit of scuba diving. I'm 58 years of age and I still feel 18, and I still love doing this job as much as I did when I started doing it back in 1980 as at the tender age of 16. So we'll get stuck straight into this then. So the first thing to understand is, what is an exit? And this is not specific to RACF, okay? This is a point in an IBM or a vendor provided piece of code where we can break out and we can do our own stuff. We can add additional processing. We can add extra security checks. We can go and change data. We can actually change the return codes from certain things. So if you do a security check, RACF passes back to what we call the resource manager. So if you're trying to allocate a data set, DFP is doing the work, and RACF will pass back to DFP typically one of 3 return codes: 0, 4, or 8. 0, the answer to your question is yes. 8, the answer to your question is no. 4, I don't have enough information to make a decision. You need to decide. So that's what you get back. You could change that. So you could have a RACF exit that effectively said, if it's Monday and it's Mark's user ID, change that failure return code 8 to its return code 0, which would effectively give you access to everything on the system. So there's many different exit points in RACF. Yeah, we've got 12 or 14. I've got them all written down for us to look at. But think about it as stepping out of the vendor supplied code, doing your stuff, and then stepping back in. Another way would be to draw this is sort of vertically, where you say vendor code, our code, vendor code, our code. So you come in and out, and you've got a lot of control here when you're working in this space. From a RACF perspective, there are two key manuals. The first one is the RACF Systems Programmer Guide, because it talks about all of the exits, how you install them, how they work, you know, when they get called. There are lots of fancy tables in the book, but it's essential reading if you want to think about doing this. The second one that accompanies this is the RACF Data Areas Manual. And the Data Areas Manual lays out the data that is available to you when you call that exit. It's usually pointed to by register 1 if you're coding an assembler. It says register 1 will tell you here is the parameter list on entry to that exit. So these are the two books that you need. I've put the 2.5 ones on. You use the one relevant to your ZOS operating system because things do change. However, the book that I actually learned all this from is one that I actually have sat on my desk here. It's a physical red book, and it was first published in 1993. I have tried to find a PDF version of it to download. I haven't been successful, but the book talks about all of the different exits, but also has lots of code samples in here for how things work. This red book is actually referenced by several other red books. We would probably have to have a word with a friendly IBMer to see if they could find a PDF of it. It used to be available on an IBM FTP site. I just couldn't get that to work. So essential reading, Sysprog Guide, Data Areas, and if you can get a copy of it, RACF Macros and Exit Coding. It's old, it's from 1993. But it's still very relevant. Okay, obviously the newer exits aren't in there, but how this stuff works, and it's a really useful read. So taking a pause and a drink of coffee. The actual RACF exits themselves. Most of the exits come in pairs, most, not all. And they come in a pair where they say there's a pre and a post exit. So if you look at the first one here, rack init. So rack init is the way that RACF creates or tests, creates an ACEE or tests the user ID and password combination supplied by a user. So ICH RIXO1 is called before the rack init is performed. So you see all of the data, you see the user passed, you see all the different parameters that are passed. Okay. You then execute the rack init, and then you have ICH RIXO2, which tells you the results of the rack init. Some of the exits allows you to drive around in a circle. So you can actually drive RIXO2 to spot a failure, pass it a particular return code 4, and get it to redrive RIXO1 if you want to. I use that as an example because I've got some code that shows you how that's done. You've then got a RACF check exit, and that is the art of performing an authorization check. Does Mark's user ID, TSGMW, have access to sys1.parmlib for alter? Excuse me. So that's the RACF check exit. You've then got the RACDEF exit, okay, which is used for defining things to RACF. Okay, I've written RCX01 and RCX02 and RIX01 and RIX02 exits over my career. Never done a RACDEF one, never seen the need. RAC list, this is the one that is where RACF classes are either rack listed into a data space by RACF or globally rack listed by something like KIX or DB2. Okay, so these are the exits there for rack list, copying those profiles from the database into storage for fast processing. And FRACF is the fast version of RACF, and FRACF comes in 4 different flavors. Okay, there's, as you can see, 1, 2, 3, and 4 exit, and we'll talk about that a little later. But you use FRACF on profiles that are held in storage, and a RACF is used for when the profiles are held on the database, depending on how you are working. There's a command exit. This is the command exit that's been around for a number of years. These are the command exits that see every single RACF command issued. Okay, there's a new one called IRR-EVX01. It's not really new. It's been out there for a good few years now. It's called the common command exit. There are instances where you may need to use a combination of all 3 of these exits. You can't do everything in IRR-EVX01 that you can in the other 2. So it doesn't necessarily replace the other 2. But yeah, most times these days, if we're working with commands and we want to manipulate commands, we'll look at IRR-EVX01, and that is the one that we're going to look at later in the presentation. There's an ACE, compression and decompression exit. Never used it, never seen the need for it, but there is an exit there. It's all explained in that RACF Sysprog guide. These are the ones that we tend to see pretty much everywhere we go these days. PWX01 or PWX011, new password and new passphrase exits. It's quite common to see them deployed, and we'll talk about those a little more. Every one of these exits has to have data passed to it. Okay, and that is all documented in the RACF data areas manual. And for each exit, there is a data areas page section in the manual. So RIX01 and RIX02 use the data area called RIXP, and then you can see RCXOP for RACF and so on and so forth. Okay, so, and it's important to understand what the data areas are, because when you're doing the research into what you can and cannot do in the exit, it's the data areas that largely dictates what data you can change. You'll have pretty much everything you need. So if we pick on one, and if we just look at the RIXP chapter from that data areas manual, it tells you about the program interface, it tells you about the mapping and all the information that's in there. So it pops up and tells you that this is RIXP is a programming interface. It's used for rat root request equals verify or verify X. This is its macro name. You can go and read this if you want to. Its DSEC name is here. But this is what's important. It contains the list of addresses passed to verify or verify X and post-processing exit routines. So when you look at the manual, you see all this different data. So it tells you, what its name is, and it gives you the description of it. And I've just highlighted one here, and it says, if this flag is set to 1, you have specified pass check equals no. And if you specify that in RIX01, you can type any password you want in the password field, and RACF will ignore it and just simply create the ACE. And if you've got this in place and you're logging onto TSO, it means you can log onto TSO with any password you want. If you've got this in place, you could submit a batch job with user equals and password equals, and the password does not have to be valid. Okay, if the exit supports that. I mention that because that's one of the examples I'm going to talk to you about in a moment. So yeah, the sysprog guide and the data areas guide, one explains to you how they work, and the data areas manual explains what data you've got to play with. Okay. If you see here, there's a little note just underneath red box. It says, if pass check equals no, the post-processing exit must issue a return code 4 to re-invoke the rack init function. And we'll talk about this later, but the code I'm going to show you, what it does, we come into RIX01 and we've got a few checks, but for the first time through, we don't do anything. In RIX02, we look for a failed password. If it's a failed password, we look up if this user ID is allowed to log on without a password. And I can see all the security folks here now putting their head in their hands going, why on earth would you want to let somebody log on to a mainframe without a password? This was actually a client who did this. They were using Top Secret. Top Secret has this function called no PW, and this is how we emulated it in RACF. This was a colleague of mine, and the code that we developed and we've improved over the years, way back in 1996, 1998. But what we were able to do is detect a password failure, look up to see if the user was allowed to have no password, set the return code 4, set the pass check equals no, redrive RIX01, and RIX01 now says, oh, it doesn't matter, pass check equals no, by password, the password checking. I'll show you the code later. So understanding the correlation between the data areas and the exits is really important, because this is where you get all your ideas from of what you can and cannot do in that exit processing. Okay. There is a couple of gotchas with exits, yeah, and that is you have to protect yourself from going round in a loop. We call it recursion. Okay, because if you're doing a rack init, it calls a rack check under the covers. So you could end up, yeah, just going round and round in a loop, not being able to log on. So you have to put some defensive code in your exits to say, do I really want to do this? Is this my first time round? Or am I, if it's a RACF exit, or am I part of a rack init? Or, yep. And I'll show you some examples of that. You've got to be mindful of, you know, understanding that you have to understand and check this, as I said, because you might need to add some code to prevent it, basically. So coding them, the fun part. Pretty much all of the exits I've written over the years and reviewed and amended are written in good old-fashioned assembler. There is some support for some of the exits in systems recs. I have heard tale of people using some other tooling, stuff like Metal C, to do this. I've never used that, so I couldn't really comment. But they're typically coded in assembler. They have to be refreshable and re-enterable. Okay, so when you assemble and link them, you've got to remember that. And when you write them, you've got to remember that. They've got to reside in some form of LPA. Okay, fixed, modifiable, pageable, yeah, or just the LPA. They have to be there. Okay, if they're not there, and for most of the exits, and I'm going to contradict myself a little bit later, most of the exits, you have to IPL. So it's part of the IPL processing, yeah, loads the exits dynamically. Sorry, loads the exits and we can't change them dynamically. I'll show you something later that will contradict that a little bit, okay? So what we're going to have a look at is one of these exits in a bit more detail. The place you start, if you've never done this before, is sys1.samplib on your machine. And in there is a sample member called RACF Exits. So this is a whole bunch of code supplied by IBM. There's various different samples in here. Okay, we are going to look at the command exit in a little bit of detail. Okay, IRR EVX01. So this allows you to check what RACF commands are being added, which are being executed, and you have the ability to change them, to completely ignore them, or to add messages, your own messages, put WUTers out there, create extra SMF records, whichever you want to do. So this is a sample, as I said, from IBM. So in here, are we looking at an add user or an alt user? We'll do a bit more of this in a moment. So I've got a little mini agenda for this. Okay, so the thing about IRR EVX01 is it's what's known as a RACF. Well, it's an MVS dynamic exit. So you actually don't need to IPL for this. So you can dynamically add this, you can test it, and you can remove it without an IPL. There is a way, and IBM have supplied sample code for this, to create most of the RACF exits with a little stub entry, which allows us to make them dynamic. It's not very common. So what I typically say to people, IRR EVX01 is dynamic, everything else is static. You've got to IPL to change them. Okay, so dynamic exit uses this function called CSV dynx. As I said, we can add or delete, we can change, we can add additional routines. So you can have an exit calling, an exit calling, an exit, and you can enable or disable it. Okay. The best part about this is no IPL. As I said, it's been around in RACF terms, it's relatively new, but it's been around since RACF or ZOS 1.3. So it's been around a good few years, quite often called the common command exit. As I mentioned earlier, it doesn't replace the other two exits that have been around for a while. You may have a need, depending on what you're trying to do, to use either ICH-CC or ICH-CN instead of IRR EVX01. That's quite uncommon. I think you should be able to do pretty much whatever you want to do in IRR EVX01 if you're just doing pretty traditional stuff with the RACF commands. The beauty about this exit is you get to see the whole RACF command before it's executed. You can change it, you can ignore it, reject it, and you can reject it with a message. So it sees RACF commands from everywhere. Operator console, palmlib, subsystem, r_admin, or a straightforward TSO command, whether it's TSO in TSO or TSO in batch. So we see every single command. So what happens, the command is parsed, checks it all out. The syntax it's checked. If you're using a naming conventions table, especially for data sets, okay, we don't call that. So we see the exact data set profile you specify in there before it's translated. If it's issued from the console, OPA commands is checked. And we now have the ability to do some pre-processing. And what we can do in that pre-processing exit is all manner of things. We can look for certain parameters on a add user or an alt user. One of our favorite, special. We could look to say that Mark is trying to give Mark 1 special. We could actually deny that in the command. Now, there is a product out there that does this for you with a policy, but not everybody has that solution. Or you can turn around and say somebody's adding a data set profile and they forgot to put the owner on it. You could force the owner to be the same as the high level qualifier if it was a data set profile, or you could put a table in there if it was an owner for general resources. So once we come back out of pre-processing, we reparse the command, but now we execute it, and the naming conventions table is called. So if you've got one of these fancy naming conventions tables that says, if you see Fred dot aster aster, translate that to prod dot aster aster or dev dot aster aster, that's when that gets parsed there. Okay. And once the command is executed, we've got the post processing, which allows us to go and do things such as extra SMF records, put WUTUs out, and all kinds of different stuff that we can do. Okay. As I mentioned, we can change it. We can build a COM area to be able to pass information back to the pre and post exits. We can fail the command if we want to, or just let it through. But you can also create your own messages, IRRV0221I message with your own text. Okay. Post processing, you can change the ACE. So you can come in, do a rack init in the pre-processing execute the command under somebody else, and then delete that ACE and pass the ACE back to the original caller, and do all kinds of housekeeping stuff should you want to. However, I say plus here, I should really say, however, the interesting thing is here, this exit gets control in supervisor state key 0. Okay. So you can pretty much do whatever you want here because you are in control with a capital K. So you have to be super, super careful with this exit. Okay. This is not one of the exits you give to a junior systems programmer to write because a small error in here or a nefarious, don't implement one that the sysprog just says, here we are, I've written it, let's get it in. It needs checking. It's a very, very powerful exit point because of that. Yeah, supervisor state key 0. Yeah, I've said it on many of the techie presentations I've done before. Yeah, you can issue any instruction, you can modify any data or storage on the system, and you're only really limited by your imagination and coding skills. That's how powerful this is. Okay, so when we start looking at this exit, its data area is EVXP. Has a couple of interesting things for us. It tells us which command was issued. So every single command has its own function code, X01 for add group, X04 for alt DSD, and so on and so forth. Apologies, folks, just had to mute there for a second. So understanding, which commands you are processing, because yeah, this exit will get called for every single RACF command. So what I typically do with this is if I'm only interested in one command, the first check that I do is it the command I want? Yes. If not, exit straight away. So come in and get out. Okay. So keep the processing really, really low for the exit, because you don't really want to get in the way of normal exit. Everything we do in these exits adds to the amount of work that RACF is doing on a very regular basis. If you put a RIX01 and RIX02 exit in place, remember that's going to get called for every start and stop of a started task, a batch user ID, a log on to Kix, a log on to TSO, a log on to your session manager, whatever your session manager is. Yeah. So these exits get called a lot. So you've got to keep the code really tight, and if you can do it in as a few instructions as possible, then do it. Yeah. Keep ahead of the latest assembler instructions, because some of the newer instructions that we've got with the latest hardware and software, instead of things that used to take us 3 or 4 instructions to do, we can now do in 1, sometimes 2 instructions. So be very mindful of that. So the parameter list that you get passed to the EVXP is very well laid out. Okay, so what we're interested in is the command function code. So I've used an example of 14 here for the R list. The flag indicators indicate where the command came from. But the bit that I'm really interested in is the command buffer, because what that says is the size of the buffer and then the offset to the start of the command and then the actual command. But what you actually see on the pre-parsed piece is the command once it's been parsed by the TSO command parsers. Okay, so if you type in LG group A, you'll notice it does LG, lots of blanks, open brackets, group A. That LG and all those blanks is in case somebody types in list G. Okay, so they have to cater in the buffer for everybody using the full version of the command or the shortened version of the command. So you got bytes 1 to 2 is the length of the buffer, 3 to 4, the offset to that first blank past the command, and then bytes 5 and onwards, the command line image. And this is the bit that you've really got to understand, is you see everything here for that command, even if you don't enter some of the parameters, because you can literally type in add user Fred, and based on your controls, Fred will get allocated or Fred will get added to that RACF database. But what was the actual command that was entered? And I'll show you that in a moment. If somebody types in setar rack facility ref, you actually see setar rack list facility refresh. So it expands all of those abbreviations because the command buffer sees the parsed RACF command, and that's important to remember. If you type in search MA sys1, you see search mass sys1 space list space all, because that's what all the defaults are. This is the one, to remember. If you don't specify these operands, then the default ones will be included. So this is what I'm saying when you go add user test user, this is what you actually see in here. So you see add user test user, the password, which would be my default group, my name pulled from me, the authority, no special, no operations, no ADC, ADSP, and all those things. So you see all of the defaults there. And that's really, that's really important to understand, because you get to see everything. So you could just simply see this and say, oh, look, Mark issued this command and it's got special in there. I'm actually going to put no special in front of it, or just blank out special. And when the command gets redriven, it will come through as not a special user. I could issue a message that says you're not allowed to give a user special, even though I'm special myself. Now, there are different ways of doing some of this stuff these days, but this is the power that you've got in these exits. One of the most interesting ways I've used this, though, is almost like a break glass type solution, because you can actually change the ACEE for the execution of the command or create your own. So Niall's our chair for today. Niall doesn't have the ability to issue commands that require RACF system special. So the command would come in, we could look at our little table, we could do a RAI check against a resource. Is Niall allowed to be a pseudo RACF administrator? Yes. Is it between the hours of 9 to 5, Monday to Friday? Yes. We could then go, okay, I'm going to do a rack init in the exit. I'm going to create an ACE for a user ID called RACF Adam. I'm going to issue the commands as RACF Adam. They'll get logged in SMF as RACF Adam. If we don't specify an owner, it'll be RACF Adam. Process the command, throw away that ACE and carry on. So whilst Niall doesn't have the ability to issue the command, we've built a process using this code to allow him to do that should he need to. And you can do that for in hours and out of hours and all kinds of different stuff. There are software solutions out there that allow you to do some of this stuff. The one thing that is important is if the command comes from Palmlib, you don't get an ACEE, so you have to go build it. Okay, so that's a thing you need to be aware of. Testing. We can use the setprog command. I would urge you not to test this exit on your production system, no matter how confident you are in your coding skills and how much testing you have done before. We can specify the library that the exit heads in. We can add, delete, or modify it. You can specify a job name just for the exit. So if you are testing it for your TSO logon ID, you can just do it for your logon ID and nobody else. And as it says here, you can activate or deactivate it. Here's what the command would look like. Yeah, set prog exit add exit name has to be IRR-EVX01. You give it the module name, the entry point. You give it the data set name where your exit exists, my.loadlib. And then you can give it a job name. So you can say job name equals and your TSO user ID, TSGMW. Okay. That allows me to just be impacted. Okay. If I have a problem, I would have to phone one of the sysprogs, because if I can't enter any commands or can't log on to TSO, phone one of the sysprogs, get them to delete this dynamic exit for me. Then I can go away and work out what the problem was and come back and do it. You have to control dynamic access, the dynamic exit facility. You've got some controls in the upper command class for set prog and set space prog, but you've also got some facility class profiles. One of the things you've got to be aware of is consoles with the sys authority can issue this, can issue the set prog commands by default. You have to put the CSV dynex exit action profiles in place, as well as mvs.set and mvs.setprog in the upper commands class. There's loads of stuff out there on how these things work. So you want to go right one. So where do you start? So other than a little bit of Rex at the end, this is an assembler overload, 15 minutes. Okay, sys1.samplib, RACF Exits. There's a whole bunch of them in here, okay? There's a PWX11 one, a sample exit that uses the system Rex that we'll talk about later. There's lots of other different samples supplied by IBM. I'm going to just talk you through a couple that I've either written myself or written with some of the colleagues I've worked with over the years. So here's a RIX01 exit. And the idea of this exit was if the user ID is allowed to log on with the password, as I mentioned before, we were supporting the no password function in Top Secret. If the user's allowed to do that, we would remove the password in RIX02. We put passcheck equals no, and we would redrive RIX01 with passcheck equals no set. So it means that the user can log on without a password. So that's just the comment block at the start. But there's a whole bunch of stuff you have to do. Okay, so the first thing is you will see here under this check call thing, yeah, we're loading the RIXP flag. Okay, are we where we want to be? Is it a change request? Yes. Is it a delete request? Was pass check no specified? Yes, I've already been here. Okay, just come out the exit, carry on processing. And then we've got some processing down here to see, is the user allowed to bypass? Yeah. Now we did it this way, and you might look at this and say, well, why did you hard code this into the exit? We didn't want to put this into a RACF profile to test whether somebody was allowed to do this at that point. We wanted the control, yeah, in the code. That was a decision for by the client, and they wanted the sysprogs to be in control of this. Not too sure that's the right thing to do today, but yeah, we built the control into the exit. So you've got a RIX01 exit that allows us to log on if pass check equals no has been specified. Okay, now how do you get there? Well, you actually get there from RIX02. And RIX02, what we were looking for here is if the rack in is a failure, what we'll go and do is look up to see if the user has the no PWD attribute. Now we've created a new profile in the facility class. So you have to come in, you have to do an authorization check. So you've got to build the ACE. Yeah, do the authorization check. If it was yes, they're allowed to do this, we'd set the flag to pass check equals no, set the return code to 4 in RIX02, which means go and do RIX01 again. Okay, so here's how we did the request equals auth. Okay, so bit of workspace, issue the RAID check, use this ACE. Okay, set the RACF release, all that stuff. But basically, we got a return code, and we said, look, if the user's allowed to do this, we would flip the bit that says patch check equals no, set the return code to 4, that then goes back and redrives the exit. I've got tons of this code, all different types of code. My email address is on here. If anybody wants to see this stuff so they can go through it and look to see how it works, I'm quite happy to supply it, but it will be at your own risk if you use it on your system. Okay, I take no responsibility. I don't claim to be a good assembler programmer. I hack my way around this stuff. Okay, I try to make it nice and neat looking, but yeah, it'd be up to you to check it and do that kind of stuff. If you're not comfortable with assembler, IBM have started supporting system recs for some of the stuff, and the one sample they give us is for ICH PWX11. So it's shipped in that RAC Exits member in sys1 samplib, and basically you can use recs now to start checking your passwords when people are changing them. You can do your own password rules, passphrase rules, sorry, in this exit. I've got samples of PWX01 for putting extra controls in, but this is just a Rex version of it. Obviously, there's a lot more people out there who can code in Rex than there are assembler these days. I personally prefer the assembler way of doing this, but I absolutely understand those that do it with Rex. IBM are extending this more and more. You're seeing some great stuff come out of the IBM development team. Folks like Bruce Wells and Mark Nelson are adding features and functions to make this stuff easier to do. I haven't actually implemented a PWX11 in Rex format before. From the reading I've done and understanding of it, it seems fairly straightforward. So that's the quick tour de force of RACF Exits. I'm a couple of minutes early because I wanted to try and get till 1:45 to leave a few minutes for questions. So I'm going to stop sharing my screen. Niall, I'm quite happy to take questions if anybody's got
I've
any.
not seen any in the chat, Mark, but if anyone does have any, then we can probably allow you to unmute and ask them directly. That might be easier.
Yeah.
So I think people should be able to unmute now. If they'd like to ask a question, please feel free to do so.
Do you think I've got away with it?
You've just been so much clarity, Mark, that I couldn't ask for more. I'm not seeing anyone discuss. What I'd say then is, if you do have any questions that you think about in hindsight, please do email either myself or Mark or anyone from the GSE team, and we'll be more than happy to pass those questions on and get a response sent over to you. And Greg Boyd says, good session too early in the AM over here. That's yeah. Greg, it's 9:44 here in the UK, and I think it's too early. So.
Yeah. I can tell you, I know where Greg's based. This is very zero dark hours here for Greg.
Oh. Yeah. Okay. Yeah. Well, I appreciate your commitment in turning up, Greg. Thank you, Pete.
James
Smith.
You very much. Yeah.
You
So
got
look, yeah, all I'd say to everybody out there is seriously, I've just logged onto my little TSO, my little emulator here. I have got 45. I've got a little assembler source library here with 45 bits of sample coding. If people want stuff, please just do email me. But you will find loads of stuff out there on RACFL, on IBM Main, on the IBM websites. And if you can, get a copy of this book if you're fairly new to it. Okay, yeah, that's how my signature used to look in 1993. It doesn't look like that anymore. It's a little squiggle. I'm too lazy these days. But yeah, please just reach out. I'm more than happy to help. Niall, back to you. Feedback.
well,
Yes, please.
Yeah.
Can I have your feedback?
As I've put it in the chat, there is a link there. Please remember to submit it to section 6F. It's going to be a bit confusing if you submit it to the wrong one and say Mark Wilson's amazing, and to someone without the name Mark Wilson getting the reviews. Although I'm sure they'll take the good feedback. Mark, would you be able to have you got the slideshow? Would you be able to just leave it up until people sort of filter out, just so they can say scan it with their QR code, just in case? I'm just thinking that might be another option, but otherwise, yeah, thank you all for attending. Thank you all for coming along to GSE and registering, and we look forward to seeing you in other sessions. So yeah, have a lovely rest of the day.
There we go.
Thank you very much, Mark. Must do wonders for your ego, Mark, seeing all these comments saying how great your session is.
I'll leave that to others, mate. That's not my style. Oh, and by the way, Niall, I did the slides are loaded up there as well.
Oh yeah, I can see them. Yeah.
Yeah. No, I've actually loaded them up to the GSE website.
Oh, brilliant.
So
people
can download them if they want.
That's a fantastic point, actually. Yeah. Sorry, I forgot to mention that. Getting peppered with requests on one of the services at the same time, so I'm sort of flipping between monitors.
Right, I think we might be done.
Yeah.
Okay.
I will drop out then. I don't know if anyone's sort of. Oh, I don't want to ask a question in front of Niall because his Hawaiian shirt is just so intimidating. But if
right.
that is
Niall, you're fine. Look, thanks very much, mate. Great job. Yeah. And Megan, thank you for all your support
as always,
well.
Megan. Yeah, thank you.
Thank you very much. Cheers.
Yeah, cheers. Bye.